my bad. I had the wrong thing showing. That's okay. Greetings, everybody. We'll start in a minute or two. Welcome again to virtual instruction. Sorry, I'm a bit homebound. Woke up on Wednesday with a cold, so I had a great spring break. Turned out my cold was a little bit more COVID-y than I hoped it to be. So I'm a little homebound for the first half of this week, which is fine. It's not a problem. I just adjusted. I didn't want to do Zoom again, so pulled up my Twitch stream. Woo-hoo. So welcome. That's what we have. So yeah. How are you guys doing? You guys there? Last hour, I had some people in the classroom watching together, which was cool. I don't know. I'm assuming they were watching together. But anyway, they went to a classroom. Maybe you guys didn't, which is fine. This is being recorded. It'll go on my YouTube channel. I will post the link to this video after it's done. Okay, so it's 3 o'clock. Since it is recorded, I'm going to go ahead and start talking. Hello. Hi, Ren. Before I talk about the midterm review stuff, so thank you to everybody who did fill out the survey. I appreciate it. It did give me some guidance on what to cover. Overwhelmingly, people wanted to talk about loops and logical indexing and branching, and then there were a couple other topics after that. So I will focus on that. Does anybody have any other questions that they want me to answer in terms of midterm information, in terms of homework information? Your homework is due tomorrow evening, so make sure you do that. I did post some information on the midterm exam this weekend on UB Learn, so make sure you go over to the midterm tab. There's a midterm review folder in there where you can see essentially what to expect on the midterm. That's where you found the survey. There's also a practice exam, so make sure you go do that one. There's problems, and I posted video solutions outlining essentially how I solve them, what keywords to look like, how you should approach that. All of those videos are, it's less than an hour. And then I also posted links to your homework solutions. So go look at those. When it comes to your midterm, I also posted the location and the time. So for the midterm exam, it's all Thursday at 7 p.m. So make sure you're marked that on your calendar. You're ready to come at that time. We are in 2 different rooms. So in Cook 121 or NSC 205. If your last name starts with A through O, you will be in Cook 121. If your last name starts with P through Z, you will be in NSC 205. That's just the rooms that we had access to. Not my choice, but I don't have control over all the rooms. What you should bring: your laptop charger, and a student ID. So all of those things you should bring to the midterm exam. If you do have known issues with your laptop, such as a laptop that doesn't hold a battery for a long time, email me as soon as you know that, so we can mitigate some of that ahead of time. I'm going to ask my husband if I can steal some power strips from our house to take with me. Maybe that might help. Yeah, so all of that information from the midterm is there. It's posted on UB Learns. Go look at that. Look at the practice exam. I'm not going to go over the practice exam problems today and Wednesday. I developed some new stuff. It's not as fully formed, but I wanted to go over the general concepts and what keywords to look for and the general design. KGJ47, that's not a very specific question. Can you be a little bit more specific? I do have the lecture videos from before spring break, Friday before spring break. The last 20-ish minutes of those do go over essentially how to approach each problem in homework 7. So homework 7, problem 1, creating the n-by-n matrix. For that problem, have you rewatched the video from Friday before spring break that talks about things? I mean, so in general, anytime you're asked to iterate through an array, you need 1 loop per dimension. It's not always the case, but the general rule is 1 loop per dimension. So if you're looping through an array with rows and columns, you need 2 for loops. Generally 4 loops. Not all the time, but most of the time it's 4 loops. For the number of rows, for the number of columns. And then work through essentially an example. So if you were doing it by hand, if you had to change 1 value at a time, if you had to change 2, where would you get the values from? If you had to change 2, 3, where would you get the values from? If you had to change 2, 4, where would you get the values from? That's essentially how you approach that problem. Or go through, look at, rewatch the last, I think it starts at like minute 32 for section D. Go back, look at the videos from Friday. They would be under week 7 material, lecture videos, and then section D, lecture 3. But that's a good starting point for each of the problems, and then it's filling it out from there. Okay, anything else? Any other questions? Hopefully some of that made sense. Keep typing in questions as we go along. The chattier you are, the better I can respond. But if you don't have questions, that's fine as well. But let's go ahead and look at the review material. Okay, so like I said, I have a bunch of scripts that I created that go through the different types of problems that we might see. Your midterm exam has 6 problems. They are smaller problems, similar to the practice problem, less similar to your homework problems. Your homework problems are a little bit bigger than what you should expect on the midterm. But if you do want to use your... sorry, I need water. But if you do want to use your homework as a resource, then look at your homework and look at what are the keywords you see, what are the different constructs you needed to use in your homework problems. Well, that's a good question. I forgot to talk about the plotting material. Okay, so thank you, Ren. So the general flow of this week is we have review on Monday and Wednesday. I wanted to focus on review because our midterm is on Thursday. On Friday, there is no lecture. There is no class on Friday. There's no streaming. There's no nothing. What I did was technically we were supposed to go over plotting today, but plotting's not on the midterm. So I was like, let's just skip over plotting, focus on review, and then on Friday / this weekend, I created, 5 different videos, I think, on plotting. It's less than an hour. It's about a lecture length. It's about 50 minutes, I think. I can't remember. That goes over the plotting material. Take the time on Friday to do that. Focus on the midterm. And then on Friday, watch the plotting videos. Start on homework 8. There's 2 homework 8 problems. The test code looks to see, it's like essentially a checklist to make sure all of your figures have the right stuff. But that's my recommendation. Focus on the midterm, and then after the midterm's done, then go ahead, watch the plotting videos, and start homework 8. But I wanted to focus on midterm review material because the plotting's not on the midterm. So, yeah, hopefully that answered your question. Okay, let's talk about content. So like I said, everybody inevitably want to talk about loops, which makes sense. I do want to mention that loops is only on one of the problems in the midterm. So it only shows up on 1 out of the 6 problems. Other topics, generally a problem focuses on 2 or 3 topics. So input output with branching, or array manipulation with calculations with functions. But looping shows up once on the midterm, and there's 2 different loops, for loops and while loops. So for loops are used when we know exactly what the numbers are. So use when we know exactly what numbers we're going to iterate through. So essentially like 1 to 7, 3 to 19, 0 to 100. If you know exactly what numbers you're going to go through, use a for loop. A while loop can be used, or is used, when we are going to continue for a given condition. So if our looping stops based on a given condition, we're going to use a while loop. In general, while loop is generic, for loop is not generic. Some keywords, so if you're reading through a problem statement and you're trying to figure out, okay, should I use loops, should I not use loops? Some keywords you should look for would be repeat. Repeat something means you're going to use a loop. Iterate through something means you're going to use a loop. While this occurs indicates you're going to use a loop. For these values indicates a loop. If it says use a loop, you have to use a loop. And if you see your capital sigma, like you do on your calculate pi problem for the homework, that also indicates that you're going to use a loop. So all of these keywords are ones that indicate I need to use a loop in my problem, in my solution. In general, if you need to use a loop, make a comment. So I know I need to use a loop for this problem because it says the word repeat. I kind of note that in the videos looking at the problem solutions. Keep in mind your problems. Once again, I need a drink. Keep in mind your midterm is going to be taken on your exam. It's going to be box. They're going to be problems on box. You are going to be randomly assigned 6 problems. So it'll link to box and you'll just have it pulled up on your computer. You do not have pen and paper. So any comments you insert in your files is a good indicator for us that you are taking notes, that you're understanding what you're trying to do. Keywords apply for while loops as well. So any of these, it just depends on how you're going to construct. If it says while, it generally means use a while loop, and for, it generally means to use a for loop. But anything else could be a while loop or a for loop. So repeat could be a while or for. Iterate could be while or for. Generally, iterate is for, but not all the time. Loop means while loop or for loop. Any of those can indicate whichever kind. Okay, so your problems on the midterm are going to be much more well-formed. These are just sample problems, so do not think that these are perfectly developed. But here it says estimate the value of sine using the following series equation. Sine of x equals, so if you haven't taken Calc 2, a series essentially is that capital sigma. Combat Kyle, that is a very good question. Can we look back on previous notes that we have in MATLAB? For your midterm, it's taken on your computer. You can use anything in MATLAB. You can use anything on UB Learns. You can use your previous notes in general, pull them up on MATLAB. You can use anything on UB Learns, which means previous homework solutions. You can use anything on Zybooks. So we will be in the classroom, and myself and the TAs will be walking around and monitoring your computers. But in general, it's open note. It's just not open Google, really. But if it's on Zybooks, if it's on MATLAB, if it's your previous material, all of that's just fine to use. You shouldn't really need more than that either. Okay, so estimate the value of sine using the following series equation, where n starts at 0 and goes to infinity. So I have my capital sigma. My capital sigma Melissa, would we be able to look at our notes on an iPad? That is a good question. You should be able to get notes from your iPad to your computer. I would recommend you do that. I will clarify. Yeah, get your notes from your iPad onto your computer. If you can't figure out how to do that, come to my office. Actually, no. Schedule a meeting with me remotely, because I won't be on campus until your midterm. And I can help you figure that out, but you should be able to. You know, I'm gonna send an email to the other instructors and clarify some of these questions. I will send out an email clarifying what you are allowed to use / not use when it comes to your own personal notes. Ran in terms of a paper notes, my initial thing would be like, sure, go ahead, I don't care. But I need to talk to the other instructors first. So I will send out a clarification email and get back to you guys. Good questions. Very good questions. Okay. So, estimate the value of sine using the following series equations. So we've got a capital sigma. It's not on here because I can't do an equation in MATLAB like a normal one you'd see on paper. But it is capital sigma, where n starts at 0 and goes to infinity. Capital sigma indicates I need to use a loop. N starts at 0 and goes to infinity. That's another phrase that essentially indicates I'm going to use a loop. Okay, so it doesn't say to use a while loop or a for loop for this one. I'm going to demonstrate both. For a for loop, it might look something like this. For n equals 0 to 10. So however many iterations you need is fine. So what am I repeating for a capital sigma? You are essentially repeating sum equals sum plus new term. That new term is whatever is next to the sigma. So new term equals this equation. This equation is not in MATLAB syntax, so I need to go ahead and convert it into MATLAB syntax. So negative 1 raised to the n divided by 2 times n plus 1. This exclamation point means factorial. So I can use the factorial function, and then x raised to the 2n plus 1. I need an x value, so I can go ahead, once again on your midterm, you would be given explicitly what an x value is. I'll just choose x to be pi over 3 because we're estimating sine of x, sine of pi over 3, using our equation. This is a for loop. Essentially, for n equals 0 to 10. What am I repeating? I'm repeating this. Another thing we can do inside of a loop is print out data inside of a loop. So to print out data in a loop, we would say f print f, and then we would identify essentially all of our pieces. So n equals that number. And then I would do my term. That equals %f, and then sum equals %f. But I'm just identifying how I want things to be printed out. I want to print out the words n equals, and then insert a number, comma, term equals, insert a number, comma, sum equals, insert a number. Where are those numbers coming from? The first one comes from my n value, the second one comes from my new term value, the third one comes from my sum. I can go ahead and run this. As a general note for your midterm exam, you will have lots of partial credit that can be allowed. On Wednesday, I will go over my recommended how to approach doing the midterm exam tips and tricks. But you'll have lots of partial credit, so if your code doesn't run, that's completely fine. If you are not comfortable enough to where you can write your code and know exactly what your errors might be, then don't run your code. To the best of your ability, write what you have. Use comments whenever necessary. So here are my n values. Use comments to fill in some of the gaps. Use comments up here to describe what you're doing if you want, if you have time. It's really up to you on how much or little you want to put in your script files. When you submit your exam, it's going to be only your M files. So we don't see anything that's written on paper. Everything's going to be graded just on your M files. So if you have problems being like, I don't know what it's supposed to look like, write out what you think it should look like, and then add in a comment stating, I know this is supposed to do this. however you want to do it. Okay, but over here we can see it printed out our end values, it printed out our term values, printed out our sum values. It's not nicely lined up, but who cares right now? You have something and you're like, whatever, I'm good with what it's given to me. Other things we might be able to print out might be our error. So error equals absolute value of, I'm estimating sine of x, so sine of x minus my sum. I can also print out my error. As a general note, put a semicolon at the end of every single line of code, including fprintf. Fprintf will always print out, even if there's a semicolon. Put a semicolon everywhere else. Okay, so here's where it prints out. So here we go. This is what it might look for a for loop. This is what it might look like for a for loop problem. So you can see there's not that many lines of code. It's not very big. So this is something that you might expect for your midterm exam. So that's what it looks like with for loop, where we have a specific set of numbers. So n starts at 0 and goes all the way to 10. For a while loop is used when we continue for a given condition. So if I might be asked to use a while loop, maybe I'm asked to say, calculate the value of sigma, calculate the value of sigma, or calculate the value of sine of x, or estimate the value of sine of x, while the new term is greater than a specific number, or until the new term is something. So why is the error inside of the loop and not outside of it? So it really just depends on what you want to do. So I'm printing out the error with every iteration. I can't do that if error is outside of my loop. So if you want to know the value of error inside your iteration, you would need to calculate it, or at every iteration, you would need to calculate it inside of your loop. If you're only interested with it at the end, like you are with your calculate pi function, you would do it at the end. It really just depends on when you need it, when you might be printing out, when you might need it to be calculated, on whether or not it goes inside your loop or outside your loop. So let's look at the while loop statement, and that also goes into your question as well. So while n. So let's say I want to do this calculation. So I want to do this calculation again in a while loop, and I want to do it, so stop when my error is small, which means continue when the error is large. Then you essentially be told what it means to be small versus large in terms of your tolerance. But this is what you might write next to your while loop to give you an indicator, okay, this is what I want to do, this is what I know I should do. That way when you write your conditional, and maybe it's not perfect, we know as people grading, that, okay, you know generally what you're trying to do, and you just didn't have time to fully debug. So while my error is greater than, so when my error is large, I will define large as larger than e to the negative 10, or negative 6, whatever. It doesn't really matter for this problem. You would be told explicitly what that would be for your midterm. So while error is greater than e to the negative 6. I can also print things out inside of here as well, and we can see how things change. So keep in mind, when you have a while statement, you need some sort of, oh, that's what it was. I forgot to start sum at 0. That's weird. I don't know why it didn't error out on me. So x is still pi over 3. Sum still starts at 0. And now I need my error. I can just error equals 1. Whatever. I don't care as long as it's big. Bigger than 1 e to the negative 6. So now when I run it, I ran into a infinite loop. I forgot to have an end term. So n equals 0 here. And now n equals n plus 1. If you run into an infinite loop for your code and you forgot n, that's totally fine. On your midterm exam, you don't get 0. You get plenty of partial credit. You might get a couple points off for that. But it's not overly significant like it is on your homework, where you have a testing file, you have time to debug it. But here, it's not as significant. If you do make a mistake and your code doesn't run perfectly, it's not the end of the world. In fact, I would encourage you not to even really run your code until you've written all of your problems. I'll talk about that on Wednesday. Okay, so let me go ahead and run it one more time. So here we go. Here's my for loop, all through 10 iterations. Here's my while loop. So now I stopped short because my term, or my error, is smaller than 1 e to the negative 6. Okay, so back to the whole idea of when error might need to be inside the loop and not outside of it. So for my while loop, for my for loop, error did not need to be inside of my loop. I just wanted to print it out at every term, so I needed it inside my loop, so I had it differently inside my term. I didn't need it though. I only wanted it to be there. You will be told explicitly what needs to be inside your loop though. Okay, for my while loop though, my conditional depends on error. So here I need it to be calculated inside of my loop because I need it to change every single time. Okay, so depending on what you're calculating where really depends on what you need your loop to do, what you need at each iteration. Here, I wanted to print it out, so I needed it inside, but I didn't really, it wasn't essential to my loop. Here, I wanted to print it out, so I need it inside, but it's also essential to my loop. So it really just depends on what your loop looks like, what kind of loop you're using, what you want things to do. Okay, so that's loops. Once again, there's one problem on your midterm that deal with loops, and notice they're relatively shorter problems, and you should be able to do most of them within 10-ish lines of code. Okay, so the second thing students wanted me to inevitably go over was logical indexing. So logical indexing is, we have normal indexing. So indexing is where we want to grab values out of an array. We have our traditional indexing, where it's based on rows and columns, where we can say grab these values in a vector or grab these rows and columns in a matrix. We saw that back in week 3. In week 6, we introduced logical indexing, where now we can grab them based on some conditional, where we can say grab the values within a certain range, or grab the values that are, even, or grab the values that are odd or positive or negative, but it's based on a conditional. It's still indexing though. It just so happens it's based on a conditional, which means it's logical indexing, logical being true and false. Okay, some keywords that indicate that we need to use logical indexing would be if you're told do not use loops or branching. That is a good indicator that you don't, or that you have to use logical indexing. So if you're told do not use loops or branching, generally that means use logical indexing. If you're told to count values in a specific range, count values in the specific subset of numbers. If you're counting, that means use logical indexing. If you're counting, generally it's going to be sum and then your conditional. So you want to sum up or count all of the values based on this conditional. So all of the values where it's equal to 7 or equal to 0. So that's how we would count. You also might be saying grab values within a certain range. That's also an indicator that we want to use logical indexing. If you want to grab values, then it would be the array and then your conditional. These are your two different, essentially your two different versions of where you might use logical indexing. If you're counting all the values or if you're grabbing all the values. But that's your syntax. But here's your keywords. You're told not to use loops or branching. If you're counting values in a range, if you're grabbing values in a range, those are good indicators that we're going to use logical indexing. There are other, so your homework problem and this example look at calculating a piecewise function using logical indexing. You can also look at the practice exam. That one has an additional problem that looks at logical indexing. But this is the general idea. Okay. Lost my thought. Oh, right. Okay, and then for indexing, another thing that we're generally talking about are two sides to our equal sign. So what do we want to change? And what do we want to put there? Or where do we want to store something? What do we want to store there? So we got two sides to our equal sign. We're looking at what do we want to change? Is it an entire array? Is it part of an array? What parts? Is it based on rows and columns, or is it based on some conditional? What do we want to put there? Is that part of a set of numbers? Is it an entire set of numbers? Is it only certain numbers? What is that based on? Rows and columns, or based on a conditional? Okay, so let's look at this problem. It says calculate the piecewise function. Calculate the piecewise function. Y equals, and then I have 3 different ranges. There are many ways to do this problem. Let's say my x vector is from -10 to 10, and I have a spacing of 0.1, so I have a lot of x values. In fact, it's 201 x values. I forgot to put a semicolon. It's 201 x values. Okay, so I have lots of x values. But I want to go ahead and calculate y based on what my x values are. It's not just rows and columns anymore. I could figure out what those rows and columns are, but it's not. I just have my conditional. I have the x values between -10 and -3. What are those x values? So x1, I'm going to grab the x values between -10 and -3. X, where x is greater than or equal to -10, and x is less than or equal to -3. So here, I'm taking my values in x. Which ones? The ones between -10 and -3. There are other ways to do this problem. Lots of ways to do this problem. This is one of the ways. So if I wanted to count them, I would literally just change this to sum. Once again, the difference between counting values and grabbing values. What goes in front of my conditional, sum or array. And then I can find my x2 values. That's not an x. My x2 values would be where x is greater than -3 and x is less than 3. Here's my x3 values. X is greater than or equal to 3 and x is less than or equal to 10. So what do I want to change? What do I want to store? Where do I want to store something? I want to store something in x1. What do I want to store there? Values in x, where x is between -10 and -3. Now I can go ahead and calculate all of my y values. So y1 is going to be 7 times x1 squared plus 3 times x1. From this point, really, from a long time ago, anytime you do a calculation, we should be stopping to think, am I working with scalars or arrays? Do I want to do matrix math or element by element math? Okay, so for this question, for this one, I'm working with arrays. These are vectors here. So I'm asking, do I want to do matrix math or element by element math? If your answer is element by element math, you need your period in front of your asterisks, your carets, and your division signs. You don't need it technically in front of the 7 or in front of this one and in front of this one, but you're not penalized for it. So there we go. There's our y1 values. Now we have y2 values. It's going to be sine of x2 times exp 2 times x2. Once again, I'm working with arrays, so I need a period in front of all of my asterisks, divisions, and carets. And then y3. Same equation as y1, but with x3 values. There we go. This is one of many ways to do this. You can do this separately like this. You could do this all in once if you wanted. I'll show you guys how to do that in a minute. Now I'm going to go ahead and concatenate. So in general, when we're doing logical indexing, it might be combined with array concatenation, but really we're modifying arrays and changing arrays. Instead of it being based on rows and columns, it's based on a conditional. So anytime you're doing concatenation or you're combining, I want to go ahead and create a new array, and I want to place my y1 values you can go ahead and write out what you're trying to place in places. So if you think that you're a little bit confused on where numbers are supposed to be or what you're trying to do, write a comment. So values where x is between -10 and -3. Values where x is between -3 and +3, etc. But if I would do that, it would look like this. Y is equal to y1, next to y2, next to y3. And there we go. So if we use element by element, even when it's not necessarily needed, so you're not penalized for it. It operates exactly the same. I don't think there's a time difference. There might be some minor issues behind the scene when it comes to MATLAB. As you become more comfortable with MATLAB, you'll notice yourself having better habits and cleaner habits. But if it is something you are concerned about, just go ahead and put the periods in all over the place. You're not penalized for it. It's not an unsafe thing to do. It's not really gonna diminish your time. I don't think that MATLAB handles it differently under the hood or not, but you're not penalized for it. It's not an unsafe thing to do. Okay, so that's what it looks like for this whole problem. Once again, we're looking at less than 10 lines of actual code. Add in as many comments as you want. Another note about comments is you are not graded on them. You will not be, points will not be taken off for not having them unless the problem explicitly states that you need comments. The locations where you might need comments would be in functions. So in your functions, you have your H1 line, your help text lines. If you are told when writing a function that you need to have comments, put in comments. If you're told you don't need to have comments in your function, then ignore them unless you have extra time, but you're not going to be graded on the comments that are there unless they are needed. So the problem will explicitly tell you whether or not comments are needed. If it's not a function, they are not explicitly needed. But once again, if you do have comments, it might help give context to what you are trying to do or what you want your code to look like. Okay, this is one way to do this problem. Comments could get you partial credit. Yep, if you were trying to explain what your code was doing. I am developing the rubrics tomorrow with my TAs, but I will mention that students could get think about comments as a potential partial credit, as a way of indicating that they know, you guys know essentially what you're trying to do. You're trying to develop your code in some way, shape, or form, but you don't have the full syntax. That's fine. You can use comments. They can get you partial credit. Yep. Okay, another way we can do this problem is we can do it all in place, where essentially I can say x looks like this, and then I can say y equals the same thing. So I'll start out as y of zeros, and that's the size of x. So this is proper syntax. You can do this. This is completely valid. You can also say x is the length of, or length, len is the length of x, 1 len. That is also completely valid. But you can start out with your x values and then go ahead and fill in your y values, which is zeros, and then we can fill in y one at a time. So once again, going back to what do we want to change? And what do we want to put there? I want to change y. Do I want to change all of y? No, I want to change part of y. Which part of y? The part of y where x is greater than or equal to -10 and less than -3. What do I want to put there? I want to put this calculation. 7 times x squared plus 3 times x. Once again, which part of x? I don't want to do all of x, I only want to do part of x. And then don't forget your element by element operations. So this is another way that we can do our code. same thing, but it's all done what's called in place. Essentially, we don't have separate variables breaking things out like we did up here. We can do it all in place. So this is also the same idea. It's still logical indexing. We're just starting out with y as a bunch of zeros, and then I'm only changing the parts of y that I want to change one at a time, and I'm replacing them with the calculation where x is only grabbing specific values of x. So this is also completely valid code that you might write. So you can see there's multiple ways to do things now, but this is logical indexing. Keep in mind that it probably, generally these problems are combined with concatenation. So if you think about, okay, what needs to be in this part, what needs to be in this part, how do I do that? Are you trying to count values in a specific range? Are you trying to grab values in a specific range? If you're counting them, you're going to use the sum of your conditional. If you're grabbing values, you're going to use the array of the conditional. So the array that you're trying to grab the values from, and your conditional. Okay, but those are logical indexing problems. This is another piecewise calculation. There's some practice exam problems as well. There is a practice exam problem as well that you can use as a guide for other ways that logical indexing problems might be asked. Okay, the third one and the final one for today is branching. So this is the third topic that students wanted me to cover, or the top three. We'll go over more on Wednesday. But this is the next topic that students really wanted me to cover: branching, if statements, and switch statements. There are two types of branching statements: if statements and switch statements. The practice exam has a switch statement example, so I'm going to focus more on if statements here. I do go over if statements as well over there, but I'll focus more on if statements here. Switch statements, though, as a review, use these when we have one variable compared with multiple cases. Those cases need to be integers or text. So we're comparing one variable with multiple integers or multiple text options. Use an if statement anytime else. Any other time. So an if statements are generic. Switch statement is a specific option. In general, it's easier to use a switch statement when we are comparing text. We don't need to worry about whether or not using a switch or string compare, double quote strings, single quote strings, any of those little nuances when it comes to strings. So switches are easier when it comes to text, but you can use an if statement. On your exam, keywords that indicate whether or not you're going to use a switch statement would be if. If, generally an indicator that you're going to need to use a branching statement. Sorry, not switch, branching statement. Choose, if you're trying to choose between multiple options, that indicates you're going to use branching. If you're deciding, if you're determining, those are all keywords that generally indicate that you're going to use branching. Unfortunately, there's not many keywords because branching can show up in many problems many different ways. If you have to choose between one of multiple options, you have to use branching, but it's not always explicitly stated. Because sometimes you just need to think, okay, do I need to choose between one option or another? If you are told explicitly to use an if statement, use an if statement. If you're told explicitly to use a switch statement, use a switch statement. You should be able to review both of those syntaxes. If you forget the syntax for one, you do have the resources to look it up. If you use an if statement instead of a switch statement, it's not the end of the world. Once again, there's multiple chances for extra credit. Okay, so here is my very boring case example that we can use to determine if a number is various options. So given a number, determine if the number is positive, negative, even, odd, prime, integer, or non-integer. Okay, so it says determine if. Determine if. Both of those are keywords that indicate I need to use branching. I have multiple options. A number can be positive or negative. It can be even or odd. It can be, I'm going to take out prime. I'll leave prime in. It can be an integer or a non-integer. So identify how many options you have. First things first, we need a number. In general, the number is typically from the user. So we use input number. And then I'm gonna go ahead and break this up into multiple if statements. So a number, let's say there is no extra credit anywhere really in the class. It's generally not how we do things. No. The general answer for that is no. There is no extra credit on anything. If that changes, I will let you know. Okay, so I'm gonna go ahead first decide if something's positive or negative. So here I have an if statement, or I have a branching statement. I have two options. Options, positive number or negative number. So if you have an if statement and you have two options, you have an if and an end. Did I say extra credit? I may have said extra credit. I meant partial credit. I talk a lot. So if I ever say something, don't feel bad about asking me to correct myself. So in general, for the number of options indicates your number of branching statements. So positive or negative means I have an if and an else. If you have more than two options, you would have an if and an else if and an else. So you have one set of branching given the number of options. So if num is positive, it's going to be greater than or equal to 0. So once again, this is where you might add in comments to indicate that, okay, this is the branching that says it's a positive number. Because maybe you're like, I think this is what the conditional is stating. I don't know. I'm checking to see if it's positive. Which means else if num is less than 0, this would be your negative. You don't need this, because if it's not positive, it's negative. But you could have that in. So then you can go ahead and display positive number. Sometimes you're going to be asked to use displays or use fprintf. If you're not told explicitly which one to use, you can use whichever one you want. My general rule of thumb is use disp if you're just printing out text or a single variable one at a time. If you're combining text and variables, my recommendation is use fprintf. Okay, so here we go. If number is positive or it's negative. And that's my first one. Then I can check if something's even or odd. So this is a separate if statement, and I'm going to check my options would be even or odd. So something is even if I divide the number by 2 and it's equal to the rounded version of the number by 2. I'm going to talk about this in class. So this would be to check for an even number. Once again, adding in comments to indicate that this conditional in plain language means this. I'm checking if it's an even number. So I divide the number by 2. If that's a whole number, then it's an even. My other option is if it's odd. So if I take the number divided by 2 and it's not equal to the whole number, it's odd. So once again, you don't need this if, you don't need this else if, because you can just have an else, but that's what it would look like. If it's not even, it's going to be odd. Those are my two options. So I can use fprintf here if I want to combine my number with my text. So I can say insert the number is an even number. That number is num. With fprintf, you need the \n. With display, you do not. And then here it's an odd number. Okay, so the next one is if it's prime. I'm not gonna write this if statement, but if at any point in time you think, hey, can I use a function to do this? Maybe you don't know of a function explicitly, but you want to go ahead and look up at MATLAB for using one. You can go ahead and do the help prime. You can use any of the documentation in MATLAB. Okay, so there's not really, prime won't help, but there is a is prime function. So maybe you think, okay, I want to use the is prime function. Sometimes you're told explicitly not to use specific functions in MATLAB. Don't use those. Otherwise, you can use functions in MATLAB. So here, if I wanted to use is prime to check if it's a prime number, you can go ahead and do that. So why can, when can we use that equality sign instead of, okay, so that's a good question. So using equality, generally we want to use equality. Use equality and not equals to when talking about, when comparing integers or double quote texts, double quote strings. This is when you want to use equals and not equals to, comparing integers and double quote strings. In general, we're talking about checking to see if an integer is equal to a non-integer. So if they're equal, they are going to be fully equal. Round should chop things off. So if we're talking about integers, which generally we are, when we talk about even numbers, you can even have an even floating point number, like is 3.2795 even? I don't know. So generally, equals, not equals is when talking about integers or double quote strings, which is a good indicator that we can use a switch statement as well. This is the same instance in which we want to use a switch. Not always, but that is a good indicator that we want to use switch. Okay, so notice, okay, so is prime. That's an indicator. Sometimes we also tell you functions that you might want to use, but yeah. One thing to note is your conditionals here might become a little bit more complex, and you might have to do something that you haven't necessarily done explicitly in your homework. In general, if it is more complex and something we haven't done in class, we do give you a hint on how to do something. So like to check if something is an integer, there is a function called isInteger. But don't use this one. It's talking about integer data types, which is something we don't cover in this class. So an integer is essentially this whole process if it's not divided by 2. Okay, so be careful about if you're going to use other functions in MATLAB that you know exactly what they're trying to do, or that we tell you not to use them or what to use instead. Okay, that is all we have time for. I didn't get through this whole problem as much as I wanted, but that's okay. We will move on to more topics on Wednesday. I will also go over my tips and tricks for how to approach the midterm exam. And I do not have office hours tomorrow. Sorry about that. There are other office hours hosted by other people that you can go to instead. Yeah, so I will go ahead and stick around for a couple minutes if you, oops, wrong one. I will go ahead and stick around for a couple minutes if you have more questions. Other than that, I will see you guys on Wednesday. Have fun. Yes, this lecture is going to be loaded onto my YouTube channel, and I will post the link on YouTube as soon as we're done.